All right, welcome back, guys. We are now on lesson 8.3. This is solving by graphing. So this is going to make your life a little bit easier compared to what we've learned so far. Now the calculator can do some of that work for you. So before we can get started on this lesson, we need to recall a couple things that we learned. So recall that when we learned how to solve systems of equations by graphing and then finding the point of intersection, we would do so by hitting second calculate. So on your calculator, second calculate is this trace button. Calculate, the second makes it that calculate button. 5 for intersect. Now, obviously, I don't have anything in my graph, but just so that you remember. Some other important things that you guys should know. Zoom is 0 for fit. This is going to make the graph shrink and show the most important parts of the graph on your screen. Zoom out would be hitting 3. And then one that's not listed on here, but that is equally as important that I want you guys to know, is zoom 6. And this is standard. Right, so you can look over here and see that. And you'll use that standard a lot. Say you were zooming in or zooming out. To undo it and go back to the regular graph, you would hit zoom standard. So let's practice that a little bit with problem A. So in order to type this into our calculator, the one thing that we need to remember, we do have to have it set to y equals. So the second equation is set to y equals, but this first one is not. So we can do so by moving 2x to the other side. So if we have negative 2x plus y equals negative 4, we can make it y equals by adding 2x to both sides. And then we have y equals 2x minus 4. So now we can type those into our calculator. 2x minus 4. And then our y sub 2 we'll put in the second one. So negative 1/2. I'm going to put this in as an actual fraction. So negative 1/2 x plus 1. All right. And just for the heck of it, I want you guys to hit graph and look at this graph. Okay. It looks like my graph is zoomed in because we have these thick lines. So I'm going to go to zoom and go to zoom standard, number 6. And luckily with this particular one, we can see our point of intersection. So we don't have to do anything special. But now we're going to do our intersection. So second, calculate, 5 for intersect. And we're going to move this little blinking dot to our point of intersection. And we're going to hit enter, enter, enter. And it gives us our intersection where x equals 2 and y equals 0. And we write that as an ordered pair, 2, 0. All right, now let's come back to our next one. Now both of these are set to y, so we don't have to change that or solve anything. All right, so our first one, we have negative 1.25, x plus 4. And we have negative 16. Now once again, I'm going to just hit graph so we can look at this. And notice we only see one line. We don't see the second line, so we need to zoom out. So we're going to go to zoom, 3 for zoom out. And now notice we see our second graph on the screen here that we didn't see before. So now we can hit second trace, 5 for intersect, and move our blinking dot to our point of intersection. Enter, enter, enter. And we get our intersection x equals 16 and y is negative 16. So we write that as our ordered pair, 16, negative 16. A lot of people are not sure how to get out of a graph or y equals table, so I'll show you that as well. Second mode will push up that quit button and get you back to a normal screen. All right, so now let's talk about our solutions, okay? If the problem asks you for a maximum or minimum, that is so small. So if it asks you for a maximum or a minimum, most or least, highest or lowest, all of this most or least and highest or lowest are the same thing here as our max or minimum. Okay, I'll write that down so you know. Highest would be our max, and lowest would also be our min. So when it's asking for these are things you're just going to have to memorize, unfortunately. But when it asks you for those things, we're going to answer it with our y value of the vertex. Okay, so we should know that, hopefully, when we're looking for our vertex, right? So our vertex is going to be that highest or lowest point on the graph. And once we get there, that tells us if it's a max or min. Remember, if it's the highest point on the graph, we have a max. If it's the lowest point on the graph, we have a minimum. But when we write our answer as maximum or minimum, we just want the y value of that specific point, okay? So it looks like this one is, I don't know, 1, 2, 3, maybe 3, 8. I'm just guessing pretty much. But we just want this y value, so y equals 8. Same thing over here. If this is 3 and 1, I'm just guessing to the best of my judgment, then our minimum is going to equal y equals 1, whatever that y value is of our vertex, okay? So then, the next part, if the problem tells you to find the zeros or the roots, this is when we're looking at our x values of the x-intercept. So similarly here, these are our x-intercepts, right? Where we're crossing this x-axis now. And notice we're not touching the x-axis here. So our answer would be the x value of this ordered pair. Not the ordered pair, but the x value, okay? So when we have our standard parabolas, we're going to have two solutions, right? We're crossing that x-axis twice with a normal parabola. Right, now notice that this parabola is a little bit shifted. So we're only touching the x-axis at one point. So here we're going to have one solution. And then if we don't touch this x-axis at all, which notice we're not touching this x-axis at all, there is going to be no real solutions. The biggest thing here is just to memorize what you're looking for depending on what the question is asking you. Maximum or min, zeros or roots, okay? So now let's get into our calculator solving for us. This is going to be easy, and it is the simplest way, but there are some things we need to talk about first. So the problem is asking us to find the zeros. When it's asking us to find the zeros, this is our x value of our x-intercept, okay? So in order for the calculator to give us an intersection, right? An intersection means that two lines are crossing. So in order to have that intersection, we must have two equations, okay? So when it gives you the equation of what to find the zeros of, well, we've got to figure out something to type in for y sub 2, right? So what we're going to type in for y sub 2 is the equation for the horizontal line that is the x-axis, right? So it's literally asking us the equation for our x-axis. So if we're looking up here, our x-axis, right? It is going to be y equals 0 every time, okay? Now, one thing to note, the x-axis is not an equation, okay? But we're going to type in the equation for the x-axis, which is y equals 0. Okay, so come over to your calculator and enter your quadratic into y sub 1. So we had x squared minus 11x plus 24. All right, and because we have to have two equations, you cannot skip this step. You will not be able to solve with a calculator unless you type in y equals 0. Okay, now let's go ahead and graph this just to look at it. And I'm zoomed in, so I'm going to go back to zoom standard. Right, and we can see both things here. So we're going to go to second, trace, and intersect. And we want to find both of our x-intercepts, but we have to do it one at a time. Where is my pointer? Let's try it one more time. Second trace, 5 for intersect. There it is. Okay, so that is our first x-intercept. Enter, 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 and we get 3 zeros. So remember, we're going to write these as solutions. This is the x value of the x-intercept. So if our x-intercept is 3, 0, then our solution will be, for the first one, x equals 3. Okay? All right, so repeat the same steps. Second, calculate, 5 intersect, and we want to move that to our second x-intercept. Enter, 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 and we get 8 and 0. So our solution is the x value of our x-intercept, so x equals 8. Right? So these are our solutions, and these are our x-intercepts. Biggest thing to remember here, you have to type in a second equation of y equals 0, or you will not be able to find any intersecting lines. Right? And what we typed in was that this is our second line, so that's why you can't see it on the graph. Okay, now let's talk about finding other critical values in the calculator. All right, A says to find the y-intercept for y equals 2x minus 4 times x plus 5. Notice that we have this written in our factored form. So the fact that this is our factored form does not change anything. We can type it in our calculator just like this. Our calculator does not discriminate. It doesn't care if it's factored form, standard form, vertex form. You type it in the way it was given to you. Don't waste your time sitting there trying to distribute this out and then solve it. Most likely you're not going to solve it completely correct. You could, but you're really just wasting time if you try to factor this out. So we're trying to find our y-intercept. Remember that our y-intercept has an x value of 0. So let's go ahead and type that into our calculator. Okay. Oh. So we have 2x minus 4. Oh, my 1 is still there. Hold on. And we have x plus 5. All right, so then we're going to go to our table, and we go to our table by hitting second graph, and it pulls up a table for us. Okay, in order to find our y-intercept, we're just looking for an x value of 0. So notice we have our x value of 0 right here, 0 and negative 20. So that is our y-intercept here is 0, negative 20. Right, so you can find your y-intercept in a table as long as you're dealing with integers. All right, B tells us to find the vertex for y equals negative 2x squared plus 6x plus 80. All right, let's talk about the fact of what form this is in. If we have an x squared, which we have here, this is our standard form. All right, and once again, this is perfectly fine in the calculator just to type it in the same way. So, find the vertex. So let's go ahead and type that into our graph. Clear this one out. So we have negative, oh, not decimal, negative 2x squared plus 6x plus 80. Okay, and then these notes give you very detailed instructions of how to find this. So let's start by going to our table, second graph. And we've got our table. Now, let's make this look like what the screen is showing us on the page. So notice we've got 1 and 84 and 2 and 84. So we've got some twin points right here, 0 and 84. 1 and 84, 2 and 84, same as 0 and 80, 3 and 80. These are also twin points, right? So this is telling me that our vertex is going to lie somewhere between these twin points. But the table itself does not give us that, so we've got to figure it out. So let's look at our graph. Okay, notice at first when we're looking at our graph like this, it doesn't make much sense and we can't actually tell what's going on. So this is where Zoom Fit comes in handy. So go to Zoom. I know there's not a 0 on the screen, but you can still select it. And notice how that puts a nice little graph fitted onto our screen. Okay, so from the graph in the table, right, if you're looking at this table where 72 to 80, 80 to 84, that's an increase. And then we go from 84 to 80, 80 to 72, 72 to 60. So by looking at the table alone, we can tell that we have a maximum. But if that is not all the assurance you need, you can also tell just by looking at your graph in the calculator that we have a maximum. Okay, now we want to find our maximum because we know we're looking for a maximum. Okay, that's why you need to know the difference between finding the maximum and the minimum. So now we hit second trace, and now we can use these maximum and minimum buttons depending on what we're looking for. And in this case, we're looking for a maximum. So hit 4. All right, notice it says the left bound. So let me scroll down over here so you can see the next steps. 5, 6. So we're going to go to the left side of what we know to be our vertex and press enter. Now it says right bound, so we're going to go to the right side of our vertex and also press enter. And then notice it says guess. We're going to hit enter one more time. And it gives us a maximum of 1.5 and a y value of 84.5. Okay, so notice we've got a vertex of 1.5 and 84.5. So it gave us our vertex. We can also look back at our table up here and notice that 1.5 falls between 1 and 2, and 84.5 falls between 84 and 84. So that makes sense that that would be our vertex because it's in between those two twin points. Okay, remember that our maximum or minimum, but in this case we're dealing with the maximum, is our y value of our of our vertex, right? So y equals 84.5, just that y value. And then our line of symmetry is the x value of our vertex, which is 1.5. So x equals 1.5 for symmetry, y equals 84.5 for our maximum, and then write it as an ordered pair for our... All right, now we're on part C. And if I haven't said it enough, it says it here as well. The calculator doesn't care what form the equation is in. Don't waste your time trying to change its form. The only thing about these, they must be on the same side, okay? So in this case, we've got them all on the same side. On B, we don't. I'll show you how to handle that once we get there. But let's go ahead and talk about A. It says for each of the following, find the x-intercepts, solutions, roots, or zeros, whatever the problem asks you for, y-intercept, and the vertex. Okay, so let's start with our first one. Right, we have 3 times x minus 3 squared minus 4. And then we have to put in our second equation of y equals 0. You might as well just leave that in your y sub 2. We have to have that second equation, otherwise we won't be able to find our intersections. So let's graph it just to see what it looks like. And we can see everything on there, so that's good. So now we can go to second trace, and notice it's asking for the x-intercepts. So the fact that it's x-intercepts means that we are looking for ordered pairs. I want to mention that this is vertex form. Right? Vertex form is going to be apparent by parentheses squared. Right, so come over to intersect, and let's find our first x-intercept. And we get this long decimal. One thing I want to note, when you get these long decimals, and you will get decimals a lot, round to the nearest hundredth. Meaning no more than 2 decimal places. Okay, so our first x-intercept, we have 1.8452995. We're going to round that up to 1.85, comma 0. Remember, x-intercepts always have a y value of 0. Right, now let's do it one more time and find our second x-intercept. And we have 4.157005 and y equals 0. So we're going to round that once again to the nearest hundredth. So 4.15, comma 0. Right now for our y-intercept, remember we're looking for an x value of 0. So let's go ahead and look at our table. Second graph pulls up our table, and we've got our x value of 0 right here. So this right here will be our y-intercept. We can go ahead and write that, 0 and 23. All right, now let's go back to looking at our graph, and we can tell if this is a maximum or minimum by the shape of the graph. So we know our vertex is down here, which means that we're going to have a minimum. Okay, so when we go to second trace, we're going to hit minimum, not maximum, but minimum. Right, so once again, it says left bound. So go to the left side of your vertex, hit enter, then go to the right side of your vertex. They don't have to be the same places. And then it says guess, you'll hit enter, and it gives us this maximum of 2.999993. We're going to round that up to 3, and then y equals -4. So our vertex here is going to be, hold on, sorry, my pen just went crazy. So we have 3, -4. Okay, now let's talk a little bit about the second problem. So we have -x squared equals 6x minus 3. So we're not going to move this x squared. So do not move x squared. And the reason for this, it will change your graph and your answers. So keep it in that structure. But what we can do, since we can't move this -x squared, we can move our 6x and our -3. So then if we moved 6x, we would subtract it. So then we'd have -x squared minus 6x. And then to get rid of this -3, we would add it. So then we'd have +3. So now we have an equation that we can type into our calculator. So remember, y sub 2 has to be equal to 0, but we can go ahead and change our first equation, -x squared minus 6x plus 3. Let's graph it and just look at it. Okay, we can see most of this, but not all of it. And one thing I want to talk about, this is standard form. Okay, just in case you guys don't understand that yet, standard form is shown when we have that x squared on there. So when you have an x squared, which we do. Okay, so now let's talk about our answers. So it says zeros. Zeros are going to be the x values of our x-intercept. So we can go ahead and find our x-intercepts. Second trace, intersect, and we'll just go this way because it's quicker first. Enter, 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 and we get 0.46410162. And then, of course, our y value is 0 because it is an x-intercept. But because this is asking for zeros and not x-intercepts, we just need this x value. Once again, we round it to the nearest hundredth. So x equals 0.46. Okay, and let's go and find our second one. And we get -6.464102. Okay, so our x value was -6.46. We don't want the ordered pair, we just want the x value. All right, now to find our y-intercept, let's look at our table, second table. We know we're looking for an x value of 0 here. So our y-intercept is going to be 0, 3. Okay, and then if we're looking at our graph, we know that our maximum, our vertex is up here, so that makes it a maximum. So let's go ahead and zoom out. And now we can see it fully. So we hit second trace, and we're looking for a maximum. So we hit 4, left bound, enter. Right bound, enter, guess, yes. So our maximum is -3.00000001, and then y equals 12. All of this is so minuscule, we don't care about this. We're going to round this up to -3. So our vertex, write it as an ordered pair, -3 and 12. All right, so that is pretty much it for this lesson, but I want to talk about a few things before I send you off to do your practice. So let's take a few notes up here. This is mostly about the values of your graph. So notes on the values. 1 second.
Second lunch, orange diamond, may head to the cafeteria. Second lunch, orange diamond.
All right, so this is important. If you get something like 2.99999 and the 9 just never stops, this will be 3, okay? We don't want this crazy decimal. Round it up to 3. All right, and then if we have something, say, 7.000000018 maybe. This is so small, it doesn't change the fact that this is basically 7. So your answer here would be 7. Okay, and this is the crucial one that you guys need to remember. If you have something written in scientific notation, meaning it's such a large number and it's got this power of E in there, right? Always, 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 your answer will be 0. This is important. Please remember this. Okay? I think that pretty much covers everything. Just make sure you know your forms. X squared means we're going to have standard. Parentheses means we have a factored form. And then a parentheses squared is going to be our vertex form. Okay? So, if you guys have any questions, reach out to your algebra teacher. Good luck on your practice and see you next time.